Hello guys, let's look at this question Candies in a Jar. So this is from the green book of the section Conditional Probability and Bayes Theorem. So this question I would rate it as moderate difficulty, and the reason why I'm covering this question is because if you had read through the solution, there are certain point in the solution where you might not be fully convinced of how the author has reached a certain conclusion. So, so through my video, I'll try to convince you of each and every point in detail of how the author has reached to a certain conclusion. And yeah, before I start, one additional point is that in case of probability and brain teasers, usually it is important to understand the solution completely, like to get convinced fully of each and every step, because if that is not the case and if you kind of memorize it, then if a variation of that question comes into the future, you won't be able to solve it. So having said that, let's begin. So the question states that you are taking out candies one by one from a jar that has 10 red candies, 20 blue candies, and 30 green candies in it. What is the probability that there are at least one blue candy and one green candy left in the jar when you have taken out all red candies? So essentially, there are 60 candies in total, out of which 10 are red, 20 are blue, and 30 are green. Now we want to find, so we are going to pick all 60 candies one by one. So let's declare a variable P. P is the position of the candies which are being picked. So it will be from 1 to 60. Now we need to find the probability. So there will be multiple such sequences of candies being picked, and we want to find all such sequences where the red. So let me denote R10. So R10 is the last red candy being picked, and B20 is the last blue, and G30 is the last green. So we want to find all the such sequences such that these three variables R10, B20 and G30 appear in this order, or the other order which is possible is that last green candle appears before the last blue. So only these two are the possible scenarios. Now what appears in between is of very little significance to us. So here, for example, if last red candy has been picked up, so only thing which can appear here is either blue or green candy. And here, since all red and blue are over, only green can appear. Similarly, here only blue can appear, and here green and blue both can appear. But as you'll see that what appears in between is not of much relevance to us. So what we want to calculate is the probability of these two events, namely E1 and E2. So the probability which is being asked to us is E1 plus E2. What is E1? E1 is when R10 appears before B20 and that appears before G30, and this is when R10 appears before G30 and this appears before B20. Okay. Now let's so here these are the two probabilities which we need to calculate. But you'll notice that if we calculate either one, the other would be much simpler to calculate, as it would just be doing simple fractions. Now let's focus on this one. So when we write this, what do we actually mean? So here, if I write this as probability that R10 is less than B20, and I take an intersection with P30 as G. So what I've written is that if I fix my 30th, not 30, sorry, 60th. If I fix my 60th position and I say that the 60th position is green, then the only thing which is left to remain is that the last red candy should appear before the last blue candy. So because the last green, if I fix it, then obviously it will be after blue. So this is writing the same as writing this. And now this can be further simplified using Bayes' theorem, where I calculate that red appears before blue, condition it on that the 60th position is green times probability that 60th position is green. Okay. Now we have to calculate this and this. First, let's focus on, so I'll name it 1 and I'll name it this second. Let's focus on second. What is the probability that P60, position 60 is green? So there are total 10 red candies, 20 blue candies and 30 green candies. Now if you had seen the solution, it is simply mentioned that probability that the last position is green is 30 upon 60, which is 1 by 2. But this is the point number 1, so I'll denote it by hash, where I'll go deeper into trying to convince you. So how has this come 30 by 60? So you might ask yourself as to is the 60th candy not dependent on what has appeared before that? And the answer is no, it is not. The reason is that here the probability which you are calculating is not conditioned upon what has happened before. So when they are asking, like what is the probability that the 60th position candy is green, we have no information about what the first 59 candy is. And therefore the answer would be simply number of green candies upon total number of candies, as each candy has equal probability of landing in the 60th position. If you are still not convinced, let me try to show it through a calculation. I think that would make things much more simpler. So for the calculation's sake, let's take the number of candies as 1 red, 2 blue and 3 green, so that our calculation becomes simpler. Now if someone asked you, what is the probability that in the first position, that is P1, I get a green candy? So it would be 3 by 6, half. Now if someone asked you, like what is the probability that the second position is green? So here, if I have to calculate and here I am calculating for all the scenarios of what the first candy can be. So using Bayes' theorem, I can write this as probability that position 2 is green given that position 1 is red times probability that position 1 is red plus probability that position 2 is green given that position 1 is blue times probability that position 1 is blue plus probability that position 2 is green given that position 1 is green times probability that position 1 is green. So it's basically the event E conditioned upon all the possible scenarios. Now let's try to calculate this. What is the probability that P2 is G given that P1 is R? So if P1 is R, P2 is G. So it remains 3 and denominator will become 5. Now since there are only 5 candies to pick from, and P1 is red is 1 upon 6. Okay. Now P2 is green given that P1 is blue. P2 is green given that P1 is blue, again 5, and P1 is blue. Blue there are 2 candies, 2 upon 6 plus P2 is green given that P1 is green, so number of green reduced by 1, so this is 2 by 5, and what is the P1 is green? This is 3, initially there are 3 by 6. Let's find out what this value is. This is 1 upon 10, this is 1 upon 5, this is 1 upon 5. So this is 1 upon 10 plus this is 2 upon 5. 2 upon 5 can also be written as 4 upon 10. This is 5 upon 10 and this is half, which is same as what we got when we were calculating for first position. So you see, if the information about the first position is not given and then someone asks you like what is the probability that the position 2 is green, then you have to condition it on all the scenarios of the candy which can come into the first position, and it would simply give you the same answer as probability that if I just took the number of green 3 upon total 6 half. So even though it is obvious because we are saying that the all the events are independent, and so if all the events are independent at any point, if you're picking something is the total number of available upon the total number of like the total number of green available upon total number of candies. But a doubt might arise as to when you see this, you might ask like why like what happened to the previous candies? Like, is my result not dependent on that? So just to convince you of that it is not, and even if you calculate it using Bayes theorem, where you for the previous candies you pick all the possible scenarios which can happen, you will still get the same answer as that of when you assume that the events are independent. So for P2, if you go on calculating P6, you will still keep on getting half if you condition it on all the events. So this was the first point. Now let's come back to our main thing which we are calculating. So second point, we calculated that probability that the 60th position is green is half. Now let's calculate 1. 1 is that probability that R10 is less than B20 given that P60 is green. What it says is that the last candy, which is red, appears before the last blue candy, given that the last candy is green. So this again, here, we will simply neglect all the green candies, and we will take only the red and blue candies. So there are how many? 10 red candies and 20 blue candies. And we'll say that now that all the green candies are neglected, again the question comes back to, we just have to find that the remaining last candy for these 30 candies has to be blue. So at the 30th position, I want a blue candy. So this again would become 20 by 30, which is 2 by 3. Now here I will not try to convince you as to that for how for the 30th position I get a blue candy, because this follows the same as the how the last 60th candy becomes the green. But I'll try to convince you of another thing which might arise in your mind, is that, so again let's come back to our that example, 1 blue, 2 green, and I think it was 2 red. 1 red, 2 blue, 1 red, 2 blue, 3 green. So the point which I'm trying to convince you of is, you might ask like, does neglecting green, so when I say here that I have neglected all the green and then I have calculated the probability and I have found the answer. But you might ask, does neglecting green actually have an impact or not? So like when I'm saying that I'm neglecting the green, but it is just so that my calculation becomes simpler. But in reality, the green would be getting picked at some random positions, and we have just conditioned that the last position is green, but the before 59 green, they would be getting picked at random position. So what here we are claiming is that the probability that the red is picked before blue is independent of the remaining 59 greens, no matter where they are, if we have fixed the 60th green at a certain position. So this is what I'm trying to convince you. So here, let's say 1 red, 2 blue, and 3 green. So I'm saying that this is the 6th position where I fix a green. Okay. Now here is my red, and there are 2 blues, and now how many positions are there? This is, I am just drawing these lines for all the positions where green can appear. So the remaining 2 green can either appear, so out of this 4 positions, there are 4 C2 ways. There are 6 possible ways in which you can arrange the remaining 2 greens. But no matter where those 2 greens are, for these 3 RBB, how many possible ways can you arrange these 3 candies? So there are 3 factorial, not 2 factorial, because there are 2 same greens, there are 3 ways, or we can simply write it down also. One is RBB, BRB, and BBR. Now, no matter where green appears, it does not mess with the sequence which matters to us. That is, the last red should appear before the last blue. So this is the sequence where last red appears before last blue, and this is also the sequence where last red appears last blue. This is not the sequence, as red appears, last blue is this, and red appears after that. So how many sequence in which we get our favorable outcome? 2. And what is the total number of sequence? 3, which is 2 by 3. So as you see that the remaining two greens, no matter where we place, it does not impact our probability of last red being before last blue, as long as we fix the last place. If we fix the last place as green, that's all. Okay. So now we have calculated 1 and we have calculated 2. So the probability which we were initially going to calculate is probability of E1 plus E2, and we were finding probability of E1. So this is 1 is, so this we calculated as half, and this we have 1 we calculated as 2 by 3, and this is 2 by 3. Now let's come to this scenario. This is again, if you have calculated all this, then this becomes much simpler, because now it's simply, we will just write it again, this as, let me write it on another page. We have to calculate probability that R10 is less than G30 is less than B20. Let me just see if I have noted it down correctly. R10, G30 and B20. Okay. Now here what we will do is simply the same thing. R10 is less than G30, conditioned on that, one second, that position at 60th is blue times probability that position at 60 is blue. So what is the probability that position at 60 is blue? All events are independent. So at the 60th position, blue is, total number of blue are 20, total number of candies are 60. And this is, we will ignore all the blues, only red and green remains. And we want to find that at the last position, we get a green. So how many greens are there? Total number of greens are 30, and the total number of candies left are 40. So this is 3 by 4 times 1 by 3. It will come as 1 by 4. So our total probability will come as, what had we calculated here? This had be 2 by 3 into 1 by 2, which is 1 by 3, which is 1 by 3 plus 1 by 4. This will come as 7 by 12. Let's verify if that is the correct answer. Yes, it's 7 by 12, which the author is also getting. So overall, if you go through, if you understand the concept of independence to its core, and if you are able to intuitively understand the, the steps which the author has written, then it's all good. But in case if you had like these two hash points where I mentioned, where you had doubts like how the 60th position probability of being green is simply number of green upon total candies, and how it is not dependent on the previous candies, and even if it was, um we are not worried about that. Our probability is not conditioned on the past events, and I showed how even if we calculate it using Bayes theorem, where we calculate of the position 2 being green and we condition it on all the possible events of position 1, we get the same answer which we get from independence. And secondly, for calculating this probability also, there might be some doubt which could arise in your mind as to how the sequence of the remaining 59 green does not impact this probability. So again, this you can see from the simpler case. So I hope my solution was helpful, and now you fully understand this question. And if a variation of a certain question do come in future, you'll be able to solve it. And yeah, that is all. Let me know if you have any query, address it in the comments, and I'll try to go through it and give a possible explanation if necessary. Thank you, and see you next time with another question.